Okay, Spartan fans, today we are going to talk about sequences, which are just a bunch of patterns, and we're going to talk about this new thing called factorials, which some of you may or may not be familiar with, as well as sums. Okay, so sequence is a pattern. It's a list of numbers that follow a pattern. Okay, and sequences are of all different forms. They could be arithmetic, which you're going to learn about in the other video. They could be geometric. They could be neither. So I'm just going to look at a sequence, and we're going to see if we can work backwards and figure out maybe what the formula is. So, for example, if I gave you a pattern such as 1/3, 2/9, let's change that 3 to a 4. Let's make that 4. 4/27, etc. I think if I asked you to figure out what the next number in the pattern was, I think you would maybe be able to tell me that the numerator is 8 and the denominator is maybe 81. And after that would maybe be 16/243. So it looks like in the numerator, we're multiplying by 2. And in the denominator, we're multiplying by 3. Okay. If I give you a formula, and let's say it's something like a sub n, this is the value. Basically, this is an equation of for the pattern. And you're going to learn a lot more about that in the next video. And I want you to figure out, let's say I tell you that it's -1 to the n minus 1 times n squared minus n. Okay, this is a lot of fancy notation. But if I want you to find the list for this pattern, well, if I wanted to find the very first term in this pattern, I'm going to plug in 1 for all the different n's. So every n becomes a 1. Okay, well, this is -1 to the 0, and anything to the 0 power is 1. And then 1 squared minus 1 is 0. So the very first term in this list, this sequence, would be 0. The second term, I'm going to plug in 2 for all of the n's. And so that's going to be -1 to the first times 4 minus 2, and that's going to end up being -2. And the third number in the list is going to be -1, and all the n's are going to become 3. So that's going to be -1 squared, which is 1, and that's 9 minus 3, I hope, is 6. So the numbers in these lists would be 0 would be the first number, -2 would be the second number, 6 would be the third number, and so on. So to create the list, you're literally just plugging in 1, then you're plugging in 2, then you're plugging in 3, etc. So my main goal for this video is to talk about things that are called factorials and summations. Okay, factorials. Okay, so a factorial is a very excited number. It's written with an exclamation point. And a factorial is defined as 1 times 2 times 3 times 4 times n minus 1 times n. And the important thing to note is that 0 factorial is 1. And I'll explain why that's true in a minute. So for example, and your calculator will do factorial, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the graphing calculator, there's a factorial key. I'm not sure if there's a factorial key on the scientific calculators, to be honest. Hold on a second. Let's see, that's going to be 7 times 6, 5, 4, 3, 2. 5,040. Okay. You can simplify funky factorials. The problems definitely get a little bit harder than this. So if I want you to simplify something like 8 factorial times 3 factorial over 6 factorial. Okay, well, I'm going to write it out the long way, and then let's see if you can establish some shortcuts. I don't tend to write the 1. So that's 8 factorial. This right here is 8 factorial. Times 3 factorial, which is 3 times 2. All over 6 factorial, which is 6 times 5 times 4. I'm going to stop there because 6 times 4 times 3 times 2 is going to reduce out with this 6 times 4 times 3 times 2. So I'm going to reduce and that's going to become 56 times 6, which is 336. When you are trying to simplify, start with the higher factorial. Start with the higher factorial. The larger number. Okay, so what happens when there's no numbers, though? So what happens if I want you to simplify n minus 1 factorial over n factorial? Okay, n is larger than n minus 1. Right? If n is 8, that would be greater than 7. If n is 12, that would be greater than 11. So in this particular problem, the larger value is n. So n minus 1 factorial is n minus 1. What comes next would be n minus 2, n minus 3, etc. The denominator, n. What's after n? N minus 1, n minus 2, n minus 3, etc. So, n minus... I've skipped n minus 1 in here. I forgot n minus 1. So the n minus 1 in the numerator is going to reduce with all the n minus 2, the n minus 1s in the denominator, and the result of this is 1 over n. Okay. And you can always check. Let's do a quick check. Let's say that n is equal to 10. So that would be 10 minus 1 factorial over 10 factorial. So this would be 9 factorial over 10 factorial. And that would be 9, 8, 7, 6, yada, 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 over 10 times 9 times 8 times 7. Yada, 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 1 over 10, which is 1 over n. Okay, a quick side note. You can't cross off exclamation points. That's voodoo math. So, like 8 factorial over 4 factorial. Okay, 2 things. That's not 2. You can't cross off the exclamation points. That's voodoo math. That's not true. And it also does not equal 2 factorial. Okay, so be careful. You cannot reduce factorials. Okay, and the last thing I'm going to talk about in this video is going to be what we call summation. So you're going to learn a lot of Greek in your math life. You're going to talk about alpha and beta and theta. You already know pi. We have this funky looking capital S in Greek that is called sigma, and it stands for sum. Sigma stands for sum. Okay. I'm going to give you some vocabulary. We tend to use n or k. Really, the variable doesn't really matter much. So I'm going to use, your book is going to use I and N of A sub N. Okay. This bottom number is called the index. And essentially, it is your starting term. Your starting term number. Okay. N is called the upper limit. Basically, where are you going to stop? And then this is the formula for the sequence. Okay, so for example, if I ask you to find the sum from I equals 1 to 4 of, how about 2I minus 3. I'm going to use I and N interchangeably. Every book is different. So this book tends to use I, other textbooks use N. So this means I'm going to find what happens when I plug in 1, what happens when I plug in 2, what happens when I plug in 3, and what happens when I plug in 4. So I'm going to start by plugging in 1. That's what this number at the bottom means. And I'm going to stop what happens when I plug in 4. Okay, so A sub 1. I'm going to plug in 1 for I, multiply it by 2 and subtract 3, and that's going to be negative 1. And then I'm going to plug in 2. So that's going to be 2 times 2 minus 3, which is 1. And then I'm going to plug in 3, which is 2 times 3 minus 3, which is 3. And then I'm going to plug in 4, which is 2 times 4 minus 3, which is 5. You'll also notice that sometimes you don't necessarily have to plug in all of the numbers. Here's why. You notice that from negative 1 to 1, you're adding 2. And from 1 to 3, you're adding 2. And from 3 to 5, you're adding 2. So if you can figure out the pattern pretty easily, you can save yourself the time of plugging in. So as a sequence, as a pattern, it would be negative 1, 1, 3, 5. Okay. But as a sum, negative 1 plus 1 plus 3 plus 5, the sum to that would be equal to 8. Okay, let's do one that's a mixture of a summation with a factorial. Okay, I'm going to use N this time. And this time I'm going to say N is, how about 4 to 7? So this means I'm going to start by plugging in 4. I'm going to end by plugging in 7, and I'm going to add all of those together. And this time I'm going to tell you that it's going to be, how about N minus 1 over, let's do N minus 1. Let's just do N minus 1 over N. I changed my mind. I don't want to do a factorial yet. I changed my mind on the factorial. Okay, so when I plug in 4, I'm starting with 4 because this index at the bottom is 4. When I plug in 4, that's going to be 4 minus 1 over 4, which is 3/4. And then I'm going to plug in 5. And that's going to be 5 minus 1 over 5, which is 4/5. And then I'm going to plug in 6. And that's going to be 6 minus 1 over 6, which is 5/6. I'm not even going to bother plugging in. I'm not going to show the work for 7. When you plug in 7, you are going to get 6/7. Okay. Yes, you will be allowed a calculator. Yes, you will be allowed a calculator. So I'm going to use my graphing calculator. And remember, I'm going to use the alpha, and the key next to the alpha is the variable key on the graphing calculator. And so I'm just going to literally add 3/4 plus 4/5 plus 5/6 plus 6/7. And actually, let me see if I can do it on my graphing calculator on my iPad. Let's see if that works. Oh, here it is. Not now. Okay, alpha x. There it is. So 3/4, this is going to be cumbersome, plus 4/5, that's wrong. Oh, okay. I'm not going to do it on the graphing calculator, but hopefully you could see what I just did there. So 3/4, 4/5. I'm going to use my graphing calculator that I have in my hand here. 3/4 plus 4/5 plus 5/6 plus 6/7, and then do a math frac. So if you want to just use the regular fraction bar and do it this way, and then at the end you could do math and then frac. All right, let me go back and try this again. Now I'm determined to make it work. So you could do 3/4 plus 4/5 plus 5/6 plus 6/7. Oh, look at that. It gave it to me as a mixed number. Interesting. Okay. So the answer is 1,361 over 420. Okay, and now we're going to work the other way around. I'm going to give you the list, and you're going to write it using summation notation. Okay, so last one. I'm going to give you the list, and you're going to figure out how to write that. So summation notation means sigma, okay? That's what summation notation means. All right, so I'm going to give you the pattern is 5 over 5 plus 1 plus 5 over 1 plus 2. I lied. I'm trying to do this too fast. Let's try that again. Let's do 5 over 1 plus 1 plus 5 over 1 plus 2 plus 5 over 1 plus 3 plus 5 over 1 plus 15. Okay, so first thing we have to do is figure out what's the formula. Okay, well, it looks like there's a 5 in the numerator. And it looks like it's a 1 plus. All of these start with 1 plus something. 1, 1, 1. And what are you adding to it? Well, you're adding 1, then you're adding 2, then you're adding 3, then you're adding 4, etc. So I'm going to say that's n. And how many times am I adding it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I'm going to stop at 15. So I'm going to say my formula is 5 over 1 plus n. And I'm going to start with n being 1. And I'm going to end with n being 15 because this is a 15. So this is going to be a 15. And notice n, n. So if you wanted to use something like I instead, you have to be consistent. So if you're going to say that the bottom variable is an I, then your formula has to be an I. You can't interchange. Which one should you use? I really don't care. And that is a basic introduction to sequences and factorials.